Hey guys, welcome back to the Steel Forum. Today we have a video for you on the surfaces connection component. It's one of my favorite components in SDS2. It makes those connections with planes that are rotated with regards to each other much simpler to use. It makes an initial connection. Sometimes you need to tweak it, and there are a lot of idiosyncrasies with this particular component. So spend the next 15 minutes learning how to use this component, and you're going to be happier for it. Let us know if you have any questions, and as always, join us back here on the Steel Forum.
I actually don't know what I'm doing.
That's just the way of it at this point.
I don't understand.
Oh, I hit escape. Hey! New for 2018. They fixed it.
So I'll have to cut that part out.
Yes, I guess you will.
All right, so on this particular project, we have a bunch of small channel framing members that are coming into the web of one of our header channels. And SDS isn't going to give us a connection because this channel is so short, but we do want a connection here. We don't want to go through all of the hassle of modeling this in by hand. So this is a great situation to use this particular component. So we're going to go through and kind of show you the different dimensions and the way to handle it. One of the big things about the surfaces connection component is that everything is flipped from what you would expect it to be. X is Y, Y is X, up is down, down is up. So you got to start to think about it that way. And we'll show you exactly what we mean in just a second. The other thing is to do not expect to be able to copy these. They're not copyable. I believe they updated the code, so these will not copy from one member to the other. So what you want to do once you get into this dialog box, so remember the points that you click the first time that you apply it, and hit that save button at the top of the dialog box. Save all of your stuff, all of your entries into that dialog box, and then just use those over again and apply them again. Don't try to copy the component from one to the next because it will mess around with the reference points and everything will be off slightly. Don't ask me how I learned that lesson because it'll look good. You'll think you have it, but in reality, everything is jiggered by a 16th or an 8th or something like that. So, all right, so we'll show you how to do this. Go ahead, Matt.
Okay, so just to simplify this a little bit, I'm going to go ahead and pre-select the beam that I want to attach it to. Use my keyboard shortcut AC to open up the Add Component dialog box. Pick Surfaces Connection, and then I am asked to pick the supporting surface, which I'll pick the face of this web, and then the supported surface. So I'll pick the back of this channel, and now I am tasked with vertically locating where I want this thing to be. Now, this is sort of an imprecise measurement. Just kind of eyeball it and get it about where you want it. Now, you can't really go wrong. I can't drag this thing off that plane, but yeah, you're just looking to get that vertical attachment.
As you can see, too, it seems to reference, and we're not certain about this, we don't know the code, but it seems to reference the top of that surface. So in this case, it's getting to the top of the web before it starts to get to the fillet, and that's the reference point. So it's not really a useful dimension. You can't just type something in there. You got to kind of play it by ear and figure out what you need there.
I do want to test something out with this a little bit later, but let's just, well, we can test it now. What I'm wondering is if I pick the very top of this, I suppose I would need to know how far down from top of member this is.
That's it. You got to know what that K distance is.
You'd have to pre-know. Okay. So we'll just go back to the old plan. So I'm just going to kind of eyeball it, get it about where I want it, and then we'll make it fit after. So pick some point that's roughly where I want it. And I've already kind of got this pre-set up with what we want, which we'll go through and explain sort of how this is done. Actually, the easiest way to think about this is if it was a bent plate. And I don't know if I select bent plate, will it change? No, it doesn't. Okay. So if it were a bent plate, if we want to use a shear plate, the length of it is going to be that vertical length. So that's how you want to be thinking about it in terms of these dimensions. Width is obviously the other direction. Then we've got our thickness. Don't mess with the X offset yet. That's something you're going to come back and change after. Set up your weld size, and then you're going to go through all of your X reference offsets, Y reference offsets, spacings, whole setup, rows, columns, all that stuff. We'll get into how that's all laid out in just a moment. It's going to be backwards from what you think, so when we get into explaining the axes, you'll see why this is a little crazy, or why it is the way it has to be. So we'll go ahead and run this, and I get my bolted connection. Now, if I wanted to have these bolts, what was you had me do? Put these vertically centered on the beam?
Yeah.
Okay, so I'm just going to take a quick measurement, and I see that we are 5/8 low. So I'm going to set an X offset of 5/8, and it will raise it up and put that right on the line I was shooting for.
And that's one of the biggest thing about this component is don't expect to get it right the first time. Get it in, get it rough, and then just tweak it a little bit. It's the absolute best in situations where you don't actually care all that much how far down these holes are, or if it's the perfect gauge, all of those things. You just need a connection to work. It's true a lot of the times in hip and valley work, which we're going to show you in a minute. But a lot of times it's true with stairs too, where you've got just these kind of intermediate members where you just need a connection in there. And you don't want to go through the effort of modeling all of these pieces, surfacing, and then, changing your depth, all that stuff. You just slam a connection in and then adjust it.
Right. Now, there's a couple things that you should be aware of when you're working with this, and I'll get into explaining the axis in just a moment. So you saw me change that X offset, but if you open it back up, you see it's set back to 0. This is a per use, per opening of the edit screen sort of tool. It will always go back to 0 when you're done. So if I were to, say, go back in and minus 5/8, it will just move it down and then leave it back at 0. So this is how much you've adjusted it that time. So if you screw up, and let's say you went the wrong way in the first place, and I went minus 5/8 and I dropped it down even lower, I now need to compensate double that amount in coming back up.
Yeah.
So if I go 5/8 back up, it's just going to push it up that amount that time.
Yeah. The title of that field should really be adjustment, right? Like it's going to adjust it this time. So make sure if you do use the save dialog tool, do not save that adjustment field in your save dialog, or you're going to have a bad time.
Right. Leave that zeroed out when you go to save this as a form for putting these in en masse later on. So this topmost point of the plate is your X reference point when you're dealing with the location of your holes. So this direction is your X direction. And then this direction is your Y direction. From this origin point. So,
and as best as I can tell, my best guess is that the first time they put this together, they put it together, or they used it on a column. So on a column, when you're using that member's reference points or grid system, X is that way, vertically in global, and Y is the other way. So it makes sense if you think of it that way. That sometimes I have to remind myself what all those dimensions are. I believe that's how they laid it out in the first place. We end up not really using it on columns, but when we do, everything kind of seems to work properly, or how we would expect it to.
Okay, and then when I turn that back on, you should be able to kind of get a feel for what those dimensions represented. Now you can pause and go back and see what these dimensions are. I think you can kind of make them out from here though. So 1.25 is your distance down to your first set of holes. Okay, we've got one column of holes in that X direction, and we've got 2 rows. So this is where it gets crazy when you're starting to think about this as a shear plate. This, as a shear plate connection, is 1 row, 2 columns, but in this case, with the surfaces connection, it's 2 rows, 1 column. So we've got our 2.5-inch Y reference offset, and then 2.5-inch Y spacing. We've got our holes and columns set up. I've got short slot holes, and I've got a 90-degree rotation, which is going to make these horizontal in this condition. And you can
now,
change the
one
diameter.
of the things that I would love to see added into the software, hopefully into this component specifically, is to be able to use clip angles when those 2 surfaces are 90 degrees. If we could put an angle in there instead and have control over both sides, that would be fantastic. The other thing long-term we'd love to see is the ability, and this has been talked about on the forum a lot, to just apply this as a connection and, have it just kind of like a user-defined connection, but it takes away all of that intelligence. It's the way the force button was always intended to work.
Yeah, I think the way that would have to function too is instead of this X offset, it would have to be a distance from the top. Maybe you can set it as like a third plane, the top flange of the supported member, and then come down from there to the first hole. That would be a way to do that essentially.
Yeah, and it might, it might even have to differentiate between, are you putting this on a column or are you putting it on a beam, so that it gets those reference offsets correct to what you're expecting in your head based on everything else you do in SDS2.
All right, now just to show you, and this is going to run off the beam a little bit, but so let's say we go to a 5.5, and I'm going to leave everything pretty much the way it is just to see what this does. We'll go 2 columns so you can see how this is going to give us the 4 bolts. And you can see how that reacts. So then again, once we get that sort of set up the way we want it within the material, then we want to use that X offset to bring this down to where we really want it to be. Which I should have known that was going to be 2.5, so bring that down. Probably not a big fan of the fact that that's running right off the bottom of the material. But you see that does in fact work. Now,
the great part about this component is it takes one of those more menial tasks away from you. And there's a lot of stuff like this when you're framing in stairs that you find yourself as a modeler kind of feeling lazy, right? Like you don't want to surface on that and change your view and 3D rotate and set all those reference points and put in this material, all of those things. You don't want to do that. But this component does take that away. It's almost like that force beam connection that we all dream of, where it just says, okay, here's the connection. Do it, do your worst. I love this functionality. It makes, especially when you're up against it, you're behind schedule, and you just, like I said, you need to slam a connection in there. You can do this very, very quickly and get good results.
The fact that was digging into the K was just bugging me. I had to put that back.
Yeah. And that's okay, right? Like this is the cost of having something where it just gives you what you tell it to give it you. And we're all prepared for the fallout of that. So let's take it now and let's take it into the place where this really makes itself shine. Let's go over to a hip and valley job. Now, this is a job we did a few years ago. And if we'd had this component at the time or known about this component at the time, we could have saved just a huge amount of time modeling in these connections.
Okay, so we're going to kind of fly through this one and just get a shear plate on one side, and then we're going to slam in a bent plate on the other just to sort of show how this all operates.
Yeah. And if there's some of you modelers out there, maybe you're junior, maybe you're senior, and you're just overthinking it, but the important part with these hip and valley connections is to make sure that you get a connection and that it all kind of fits on there. You don't have to worry, is it down 3 inches exactly? Is it down 5.5 for a nice round number? Get it in there, get a correct connection that all fits together. And on these hip and valley jobs, that's good enough.
Do like a 3-inch vertical spacing, I'm guessing. 3-inch space. Oh, go 2 3/4 out. Now that's got to be a 90. This is a short slot.
And don't overthink these dimensions the first time. Get something near what you want, but a lot of times you're going to have to tweak these to get edge distances that work with what you want, a vertical distance that works with what you want. Especially, a lot of these hip and valley roofs, they've got short beams, and you end up having to use 2.5-inch spacing or even 2.25-inch spacing. The AISC code, I believe, governs that the minimum distance between any 2 rows of bolts is 3 times the bolt diameter. So we're using 3/4 inch bolts, so that would be 2 1/4 inches.
Which looks like I'm going to need to fit this in.
And again, all he's doing is he's going through, finding out what he needs to adjust, making a little adjustment, seeing how it plays, and then coming back. In upcoming versions of SDS2, we hope to see that as you float these values, as you start to adjust stuff, you'll see those updates on the screen. One place where they've done great work with that is with the railings component, or it's not really a component, it's a custom member type. But that's in that member type is all the future that we see for SDS2, where it's much more visual feedback, where you can tell exactly what's going to happen based on the settings that you're putting in before exiting that dialog box. It's not quite here yet. You got to kind of exit it and then come back. But still, having this tool here, the amount of time it takes just to get that surface figured out, get that shear plate in there, the rate elevation doing this manually, it can be time consuming. And once you have these settings figured out, you can apply them much faster in frequent situations. So, I mean, that was maybe 2-3 minutes that it took us to get that, where, trust me, doing these manually took much, much longer. So let's flip over to the other side and get that bend plate in. And shear plate is hard enough, but a bend plate, getting that 3D math to get that bend right, ooh, that's a whole other story.
That's the one that'll make you cry.
Yeah, I'm convinced there's a dozen people in the whole country who can work out that math. Well, not who can work out the math, but who are detailers and can work out the math. And I am not one of them.
Now here I've also got the option to weld the outstanding leg or bolt it. I'm just going to leave it welded in this case, but we can come back and bolt it after. Let's see how this one plays out. Look at that.
Boom.
Man, that's perfect right off the bat.
Yep. Yeah, you just
other than maybe clearing that K.
Yep.
Oh, this was,
seriously,
so much time I spent doing this thing the first time around.
I mean, we spent 15-20 minutes on each of these connections just to get the planes right. You get a section that works, all of that stuff, and then to figure out the math on those bends. It's one of those things that each time I have a hip and belly job, I gotta go back to school and learn how to do that math. And now I don't have to do it anymore. And I'm happy to lose that particular skill.
All right, so if we bolt this, we get the whole thing over again that we've got down here. So I can largely just, well, let's try it. Let's just copy and paste, because I'm pretty happy with all of those numbers. So we'll see how that one flies.
Yeah.
This would be round holes, I assume. But other than that, and bam, we're done.
So is there anything else that we should show on this, do you think?
I think we've covered the simplest use and the save me from this nightmare use.
Yeah, so. And really, like, give this a spin. Even in times where your connection just, for whatever reason, you're having a hard time getting SDS to get a connection, slam one of these things in, you're going to be happier for it. Especially if you've got a progressive checker who understands the nature of, hey, it's a model, it fits. Let's move on. You don't have to know exactly how far down and all that stuff. You just got to look and make sure everything clears the way it's supposed to, and you're going to be a happy, happy camper. All right, we're going to show you one last nightmare scenario that we had to deal with. The amount of time I spent on this particular connection just to get it right would stagger you, because we have things in all sorts of different planes going on here. The one large beam is sloped and skewed, and the beam that it's framing to is coming in to it at a different angle. So there's all of these different planes. I think I spent at least an hour to get it right the first time. Now, I know that sounds ridiculous, and you're looking at it and going, oh, it's just a shear tab. What the heck is your problem? But believe me, it was not that simple. So let's see what the surfaces component can really do. One of the fun things that I love about these hip and valley jobs, though, is that there's a lot more leeway as far as what you can do for a connection, because the loads on these roofs are so tiny. What are you doing?
Well, here's the little trick to it, is you got to figure out where that piece actually is before you set it in.
Ah, okay.
You're starting to sound like me. Oh. We're just going to do this one welded and a shear plate. See what it does. I'm not even going to mess with this stuff yet. I'll just
try it.
See what it does, yeah.
Yep. But even that, right there, you got 90% of what you need. Now, if you just make a big old plate there, I could always do a cut layout if I want to do a custom hole pattern or something like that. Surface on the plate, and it's all good. It's fine. But to get that in the right plane where it sits on that web nice, major time saver. And as I like to say, minutes add up to hours, add up to dollars. That is a pretty solid start.
Yep. You can build that up from there.
Yep. A couple clips, and you are good to go. That's it.
All right, guys, that's it on the surfaces connection component. We hope you learned a lot. Hope you are able to use this in your future projects. Should save you hundreds and hundreds of man hours over the lifetime of it. We also hope that there will be some improvements coming forth. SDS2 has really been killing it on getting some of these components and little interface tweaks taken care of very, very quickly. So kudos to them, and we hope to see you back here on the Steel Forum.
I can't even imagine having to sit there and lay out that to figure that sucker out.
It's insane. It's crazy. So I think we're done.
I think I'm annoyed I didn't have this the first time.
Really annoyed, right? And you didn't do any of these. I was the one who had to go through and put in all these connections because it's one of those situations that you hate where it's just make something work, just to kind of be a little bit creative with it.
Yep. Well, I remember what we had to do here is you had to figure out the methodology. You know, what's the method to the madness? How are we going to do anything with this? And then I had the task of going around the building and making it happen in as many places as possible.
Yep.
Although I gotta say, just laying out this bent plate connection right here, that's pretty much it.
Yeah, like I might have cut out plane to get it out of that K.
Yeah. But
really, like you said, that's it.
That's the majority of it right there. I mean, it wasn't anything that was a real structural deal. It just had to be there to hold the fascia on, and so it's not like it needed calcs. We just needed to put some bolts in it so it looked like a connection.
Mm-hmm.
My shooting the outro in one spot is like a 1 out of 15 times. The intros are even worse, right? Because I never know what I want to say. And like the first intro, I'll say stuff. The third intro, I add stuff. The fifth intro, I take that stuff back out, and I'm back to the first intro. It's ridiculous. So, you know, if you're out there and you're, for whatever watching this on a blooper reel or something, appreciate the intros and the outros there. There's a considerable portion of the effort that goes into this.
There's vastly more effort put into those than the rest of the video.